everybody. Today we are discussing about a very important chapter from physics, that is magnetism. From magnetism we will be getting two questions at Eamcet level. Both the questions generally are formula oriented and some questions are directly having figure orientation as well. Let me just give you the gist of this lesson in brief. We are going to take up today till the end of the work done in rotating a magnet. Till that extent we are taking up some of the applications based on this particular chapter. Whenever we consider a magnet, usually we take that magnet is going to have two poles and the line joining both the poles is called magnetic axis, and of course the extension of this line is called axial line. Line passing through the center perpendicular to this axis is called equatorial line, and around this magnet till whatever extent we will be finding the influence of this magnet, that particular range we call that one as magnetic field. Usually when we talk about magnetic field, one is uniform field we talk about, one is a non-uniform field we people used to say. What is this concept of uniform field? If uniform field we take, the magnetic induction at every point will be same both in magnitude and direction. If at all that is the case, the field is said to be uniform magnetic field. One of the better examples for this one is Earth's magnetic field at a particular place. For example, in Hyderabad, the Earth's magnetic field is going to be constant. Likewise, in the case of a horseshoe magnet also, the total magnetic field in between these two poles, we will be finding that magnetic field as uniform. So this is the basic, and the length of this particular magnetic axis always is going to be less than the geometric length of the magnet. How much it is less? It is 5 by 6 times the geometric length, that is equal to the length of the magnetic axis. So this is the first formula we have to understand. Coming to the next one, what kind of a force that is going to exist between the magnetic poles? According to Coulomb, we people used to write the Coulomb's law over here, mu naught by 4 pi into m1 m2 by r square. m1 and m2 are magnetic poles, that is pole strengths, and r is the distance of separation between their centers, and mu naught is called permeability of free space. Mu naught by 4 pi value, of course we all know, 10 power minus 7. Mu naught is going to be 4 pi into 10 power minus 7 Henry per meter. So this is the value of constant of proportionality in this case. Likewise, if at all there is any other medium, F medium can be written mu naught mu r by 4 pi into m1 m2 by r square. What is this mu r now to be called? Relative permeability, that we can write directly as F medium by F air. This is actually the concept. Coming to the next one, whenever we talk about m as the pole strength, length of the magnet usually be taken as 2L. Then capital M, which is called magnetic moment, is nothing other than the product of pole strength and the length of the magnet. We can understand well pole strength will be in ampere meter, whereas magnetic moment will be in ampere meter square. These two are the 2 points we have to remember. And based on this logical point, they can ask you, whenever a magnet is cut in different orientations, like what happens to the pole strength? There is a bar magnet like this. If at all I consider the pole strength as small m and capital M as a moment, if you are cutting it this way any number of times, pole strength will not be varied. Whereas capital M, which is the magnetic moment, that now becomes half. So likewise, how to cut that one and all, that fellow used to explain in the problem. And according to that, we have to identify what will be the value of the corresponding pole strength and what will be the value of corresponding magnetic moment. So based on this also they may ask you few questions. Particularly when you are taking up a magnet this way, this magnet is now bent into an arc like this. That arc in what way, that fellow says? It's making an angle theta at the center of the circle like this. If this is north and this one is south, then what will be its new magnetic moment? If its magnetic moment is given as capital M, the present or new magnetic moment is going to be 2m sine theta by 2 divided by theta. This is the formula. By any chance, if it is bent into a semicircle like this, then new magnetic moment is going to be simply 2m by pi. These are the points you have to remember as far as magnetic moment that is concerned. Likewise, two more equations I just want to remind you here. That is, on the axial line of a bar magnet, when we consider a point P, which is at a distance d from the center of the magnet, and of course the length of the magnet is taken as 2L and pole strength as M. What is going to be the magnetic induction at that point on the axial line? Magnetic induction B is equal to mu naught by 4 pi 2m d by d square minus L square whole square. This is the actual formula that is to be remembered. If at all the magnet is taken as a short magnet, then we used to write the same formula this way, mu naught by 4 pi into 2m by d cube. Exactly in the same manner, when the point is taken on the equatorial line over here, which is at a distance d once again from the center of the magnet, then first of all, what is the direction of that magnetic induction you identify? It will be just parallel to the magnetic axis from north side to south side of the magnetic poles. So that is what the formula here is. B, equatorial line, is mu naught by 4 pi m by d square plus L square whole power 3 by 2. Similarly, the same formula can be rewritten for a short magnet this way. It is mu naught by 4 pi into m by d cube as such. Here 2m by d cube and there m by d cube. Therefore, when distances are equal, the ratio of B axial to B equatorial in the case of a bar magnet or short bar magnet in this particular case is 2:1 ratio. That is what actually you have to remember. Likewise, what is the torque that is acting on a bar magnet? mb sin theta. That is the formula. What is this theta? It is the angle of rotation of the magnet from the direction of the magnetic field. That is what is to be remembered carefully. By any chance theta becomes 0, that means the magnet has not been rotated, then no torque that is going to be observed there. When theta becomes 90, then the torque value is going to be maximum and its formula will now be mb. So maximum torque is mb. General formula for torque that is acting on a bar magnet, that is going to be mb sin theta. Based on this, we people used to take even the concept of tangent law also. That of course we know B is equal to BH tan theta. Now, where we apply this equation? Very commonly, while taking up the concept of null point or neutral point, basically we apply this equation. Whenever we people are placing a bar magnet such that the north pole of the magnet is towards the geographical north, then you will be finding null points on either sides of the magnet along its equatorial line. That time we write the formula BH tan theta is equal to mu naught by 4 pi into m by d cube. This is the formula that is to be used at that time. But one should understand that tan theta will be 1 exactly at this null point, because theta will be 45 degrees there. Then automatically tan theta can be taken 1. So BH is equal to the remaining. So that is the formula. By any chance north is pointing towards geographical south, then the same formula will have a different version, that is mu naught by 4 pi into 2m by d cube. This is the formula. Once again at that null point, you will be finding tan theta value becoming 1, and this time null points are obtained on the axial line of the bar magnet as such. So these points, if you can remember, doing problems or applications of this particular chapter, that is not going to become difficult rather. So in the final examination, they used to give 2 questions on magnetism. Both the questions can be answered very, very easily because they are all formula oriented generally. Let us start some of the applications of this chapter now. Let us take the very first problem. A bar magnet of magnetic moment capital M and length 2L is bent at its midpoint such that the angle of bending is 60 degrees. Its new magnetic moment will be how much? Look at carefully, this is the way he has bent the magnet. You can understand this is the magnet what is described there. At its midpoint it is bent in such a way that this angle is given 60 degrees. This is say north pole, this is say south pole. One can understand when it is bent at the midpoint, is not this value of moment becoming half of the original value now? So this becomes m by 2 and this becomes m by 2 because original magnetic moment is given as m. When you are bending it at the midpoint, automatically each part will have a magnetic moment equals to half of the original value. That is true. But if I imagine south pole over here for this portion, if I imagine north pole over here for this particular portion, south to north is the direction of the magnetic field over there. Here also south to north is going to be the direction of the magnetic field over here. Whatever the angle between these two, that angle is to be considered as angle theta. So it is not to be taken as 60 now. Directions of magnetic moment over here, directions of magnetic moment over here, if you look at the directions of these two magnetic moments, if you identify them carefully from south towards north, whatever is the angle between them, that is to be taken as angle theta in this particular case. Then what will be the result? This m1 is m by 2 and m2 also is m by 2 now. And what is the angle between them? 120 degrees. Then resultant in this particular case is going to be 2m cos theta by 2 formula. All of you can understand theta 120 means what will be this value of cos 120 by 2? This is cos 60. So you can directly write this one like this, 2m into cos 60. That of course is a half, we know very well. M means what? How much here? It is m by 2 each one. Therefore, m by 2 cos 60. Cos 60 and 2 they get cancelled. What is now left over? M by 2 will be left over. So what is the correct option for this particular question, please? Second option is going to be the correct option because this is m by 2, this is m by 2. The angle between them is going to be 120. Then automatically resultant also will be the same, that is m by 2 as such. So that is the first question for us. Let us take the second problem as such. That problem says a magnet of magnetic moment capital M is in the form of a quadrant of a circle. If it is straightened, its new magnetic moment will be how much? You can understand first of all, quadrant means what? Quadrant means 1/4 of a circle. Quadrant of a circle he is talking. That means you can imagine the magnet is bent this way. That means if I complete this way, I will be getting a circle for that. But at the same time you can understand this being north and this being south, the angle between this particular arc at the center, is it not 90? So directly we can take, let us consider its magnetic moment as m dash now. M dash, how to just write that value? We know very well, it is nothing other than 2m sine theta by 2 by theta. That is usual formula. Now how to write this value here? 2m sine theta being 90, 90 by 2 becoming 45 degrees. Fine. But theta again is 90, that I can write it as pi by 2. So what will you get now here? 4m by pi into sine 45, that is 1 by root 2. So 4m by pi root 2 will now be the value of m dash. Fine. But he don't want that when it is straightened, what is its magnetic moment? That means what is the value of capital M in terms of m dash? That is what he is asking you to calculate. Then what can we write? Pi root 2, right? M dash by 4. This root 2 goes here 2 root 2 times. So what will be the answer? Pi m dash by 2 root 2. But of course in the problem it is given m dash as m. Then what should I write here? Pi m by 2 root 2. That is now going to be the present value, which is m1 I can take up. So pi m by 2 root 2. What is the correct option here tallied? Fourth option is going to be tallied with this calculated value. So this is the method and this is the formula. One should remember, whenever a magnet is bent into an arc like, this is the formula by means of which one can estimate the magnetic moment of that magnet given. Now let us take the next problem please. Two magnetic poles placed in air repel each other with a force of 4 into 10 power minus 6 Newton. When the space between them is filled with a medium, the repulsive force becomes 2.24 into 10 power minus 5 Newton. The relative permeability of the medium is how much? He is giving us two different values of forces. One in air, that is in vacuum also it may be, and one of course in the medium. So what are the values he has given? You see, force in air given and force in medium given. Look at these values. Force in air is given 4 into 10 to the power minus 6 Newton direct. Force in medium is given 2.24 into 10 to the power minus 5 Newton, that's given. Now his question is, what is relative permeability of the medium? Already I have given you that formula earlier. F medium divided by F air, that should be the formula for relative permeability. What is F medium over here now? 2.24 into 10 power minus 5 by 4 into 10 to the power minus 6. First you cut this one minus 1 time. Take this 10 power minus 1 up. This now becomes 22.4 by 4. Then what will be this value? 5.6 will be the value. So what is relative permeability? That is a question. So 5.6 is relative permeability. Which option that is tallied now? The second option is going to be tallied with the calculated value. So this is the formula by means of which one can calculate relative permeability of a medium which is separating the magnetic poles for a certain distance like. Now check the next problem, problem number 4. P and Q are two unlike magnetic poles. Induction due to P at the location of Q is B and the induction due to Q at the location of P is B by 2. The ratio of pole strengths of P and Q respectively will be how much? Now let us check this point carefully here. He is just talking about two separate poles which are separated by certain distance, he said. So what is the distance over here? They are just separated by certain distance, that's all. It has not mentioned, that is not necessary also for us. Let us check this one. This is P and this one is Q. The distance of separation for our calculation, I take that one as D as such. Now the question is, induction due to P at the location of Q. If I take its pole strength as MP, its pole strength as MQ. Due to MP, what is the induction at this point? That is what he has given you as B. So what is that value of B now? Mu naught by 4 pi into MP by D square. This is the first equation. M by D square formula we have to take up. Likewise, what he said? Induction due to Q at this particular location of P is B by 2 he has mentioned. So B by 2 is how much now? Once again mu naught by 4 pi. Okay. This time it should be MQ by D square. This is supposed to be the second. And what is the question he is asking? What is the ratio of magnetic pole strengths of these two magnetic poles? 1 by 2 you divide MP by MQ. That is what I want. D square gets cancelled, 4 by mu naught by 4 pi gets cancelled. Is it not B by 2 now? So is it not simply 2? That means what will be the ratio now in this particular case please? 2 is to 1. So what is the corresponding option that is tallied over here? Third option is going to be tallied there. That is the concept what one has to remember in this case. So due to first one, at the point to second point, what is induction? Due to the second one, at the first point, what is induction? These are the values given. The same question has been asked in one of the Eamcet papers earlier please. Look at the next problem, problem number 5. A bar magnet of length 16 centimeter has a pole strength of 500 milliampere meter. The angle at which it should be placed to the direction of external magnetic field of induction 2.5 Gauss, so that it may experience a torque of root 3 into 10 power minus 5 Newton meter. That is the concept. Look at this one is a direct application of torque formula. That of course we all know torque is equal to mb sin theta. That is the formula generally. Out of that, what are the values he has given you? You see there. This now can be rewritten as m into 2L. Pole strength into length is called magnetic moment, into the value of B into the value of sin theta. That is equal to torque. I can write like this. Now what is the value of torque given? You see, root 3 into 10 to the power minus 5 Newton meter. Of course he has mentioned that one. Now this is equal to, what is the pole strength given? 500 milliampere meter. Milli means 10 power minus 3. So this is the value of small m. Length is given 16 centimeter. You write 16 into 10 power minus 2. Fine. What is the value of B given? 2.5 Gauss. 2.5 into 10 power minus 4 Tesla. So what one should understand here is 1 Gauss is equal to 10 power minus 4 Tesla. That is the conversion what one should remember. Hold this into the value of sin theta. In fact, our calculation should be the value of theta. Now you can directly write 10 power minus 5, 10 power minus 3, 10 power minus 2. They get cancelled first of all. Next one, 1, 2 zeros, you can cut them over here with 10 power minus 2. Then what else is left over? Root 3 is equal to 5 times 16, that is 80. That 0 on this point, if you cancel, 8 times 25 is going to be 200. So this total multiplication is over. Into 10 power minus 2 into the value of sin theta. Definitely you can cut these two zeros with 10 power minus 2. Then what is this sin theta you are getting? It is root 3 by 2. Then what should be the value of theta? It should now be 60 degrees. That means pi by 3 radian. That is the corresponding value. So what are the options given? You see, the third option is tallied with pi by 3 radian over here. So third option is correct for this problem number 5 as such. This is the formula one should remember for calculating torque acting on a bar magnet. Look at the next one now. Next problem. 3 magnetic monopoles of pole strength m each are placed at the 3 vertices of an equilateral triangle of side A. The intensity of magnetic induction at the centroid is how much? That is the concept. Such problems, in fact, one should not work out and put the answer there. Simple common sense will make you get the answer. In what way means? It is an equilateral triangle first and foremost. And we all know very well, for an equilateral triangle, this is the point what is called centroid. In fact, centroid, if you want, you just have to draw 3 angle bisectors over there, wherever they are all meeting. That is to be called centroid. Fine. Now here, there is a pole placed here, another pole placed here, one more pole placed here. Now if you take this distance as A, that is a side length, what will be this length now? A by root 3. This also is A by root 3. This also is A by root 3. Now if I imagine a unit north pole that is placed at the centroid, due to this pole and due to this pole, all the 3 forces are certainly going to be equal. Not only that, the angle between any 2 forces will be 120 degrees. Means what? The force due to 2 of them, the resultant due to 2 of them is equal to the third. That means what? The centroid will now be in equilibrium. Equilibrium means what? It is not going to be moved. The north pole, whatever is placed over there, will certainly be in equilibrium. Then what will be the effective induction at this point called centroid? It will now be 0. So no need for you to calculate, because all the three forces will keep the point in equilibrium. When a point is in equilibrium after the application of several coplanar forces, we know pretty well the algebraic sum of forces over there will be 0. That is the basic condition based on which you need not calculate this one to identify the answer as 0. So correct option for this question number 6 is going to be the third one, that is 0 will be the answer. Look at the next number, that is problem 7. A magnetic needle lying parallel to a magnetic field is turned through 60 degrees. The work done on it is W. We can certainly understand magnet is initially along the direction of the field, that is what he is talking. And magnet is like this, it is now rotated this way. By what angle? Of course, he has just given us some angle here. What is that value? 60 degrees, he said. Fine. What is the amount of work done in rotating the magnet? In fact, we know mb cos theta, the formula. Since we are doing work, we write with a negative sign, that is a point. Now here I can write mb cos 60. What will be this value of cos 60 now? 1 by 2. Therefore, mb by 2 is the value what he is giving in the problem as the work that is rather done to rotate the magnet by 60 degrees. That is the point 1. Now see the second sentence. The torque required to maintain the magnetic needle in the position mentioned above. In the same position you want to keep the magnet further for some more time. What should be the torque that is needed? Simply speaking, mb sin theta, that is the formula. But of course, all of you can understand sin 60 when you take up, is it not root 3 by 2, please? But all of you can understand the same this way, root 3 times mb by 2 I can write. What is mb by 2 given in the problem? W. Therefore, it should now become root 3 times W. That should be the required torque. Root 3 times W, that is tallied with the very first option out of the 4 given there. Same question has been asked last before year at Eamcet level. So this is actually the concept you have to understand. The formula for work done is mb cos theta and torque that is required is mb sin theta. That is the concept you have to take. Look at the next problem, problem number 8 now. A magnetic dipole is placed under the effect of two magnetic fields inclined at 75 degrees to each other. One of the fields has a magnetic induction of 1.5 into 10 power minus 2 Tesla. The magnet comes to rest at an angle of 30 degrees with the direction of this field. The magnitude of the other field will be how much? Now what is his concept? Just to try to understand, it's an application of torque that is acting on a bar magnet. Please look at first of all. There is a magnetic field this way. There is one more magnetic field this way. Let us consider this magnetic field as B1 and this magnetic field as B2. And what is the angle of separation between these two given? 75 degrees, he has mentioned that. Now when both are simultaneously acting on that particular magnet, certainly that magnet comes to rest along that direction, which is going to be the resultant of these two fields. That means, for example, as he is talking about one of the magnetic fields is 1.5 into 10 to the power minus 2 Tesla. Let us write this one 1.5 into 10 power minus 2 Tesla. How much angle it is making with this field now? 30 degrees it is making, he said in the problem. Then what will be the remaining angle? Will it not be 45 degrees, please? Because total angle is 75. This is 30. Then automatically the other angle should be 45 degrees. Now, if this magnet is in this particular position, it is in equilibrium. Then what is understood? Torque acting on this magnet due to this field and torque acting on the same magnet due to this field are equal and opposite. So what should we write now? M into B1 into sin 30, right? That now must be equal to m into B2 into sin 45. All of you should understand mb sin theta, the formula for torque. This of course being 30, I can write mb1 sin 30. This is 45, therefore mb2 sin 45. M gets cancelled. What is B1 that is given? You know, it is 1.5 into 10 power minus 2, sin 30 being half. That is equal to how much? B2 by root 2. Now, what is the value of B2 we just want in this particular problem? So, B2 can be written 1.5 root 2 into 10 power minus 2 by 2 as such. This root 2 goes here root 2 times. So, what will be left over? 1.5 by root 2 into 10 power minus 2. Whatever the units for the first value he has given you, same units are to be taken for this one also. That means Tesla. So, which option that is tallied now? Third option once again is going to be tallied. 1.5 by root 2 into 10 power minus 2 Tesla will now be the corresponding value of the second field, which is called B2 in this case. Now, look at the next number, that is problem number 9. If a bar magnet of pole strength small m and magnetic moment capital M is cut equally 5 times parallel to its axis and again 3 times perpendicular to its axis. Observe the wording very carefully. He is not telling that it is made into 5 pieces. He is talking about it is cut 5 times. Cut 5 times means what? Suppose this is the magnet. He is now cutting 1, 2, 3, 4, 5. 5 times when you cut, how many pieces you are going to get ultimately? 6 pieces you will be getting. Exactly like that. 3 times he has cut over here. 1, 2, 3. That means how many pieces you people are going to get in that side? You are getting 4 pieces. So what exactly happens? I have already told you. If you take this being a north pole and this being south pole, this type of cut will make the pole strength becomes varied like. How many pieces we are getting here? 6 pieces. Therefore, pole strength present value becomes m by 6. What about magnetic moment, please? Pole strength is becoming 6 pieces and of course length is becoming 4 pieces. So totally what happens to this m dash now? M by 24. It now becomes capital M by 24 and small m by 6. Which option that is tallied once again for this one? You see, third option again is going to be tallied. M by 6 is going to be the pole strength. M by 24 is going to be the magnetic moment of that particular magnet. Observe 5 times, 3 times. He is not making 5 pieces like 5 times he is cutting there. Remember that point carefully. See that next problem, question number 10. Some physical quantities are given in list 1 and the related units are given in list 2. Match the correct pairs. List 1 is magnetic field intensity, magnetic flux, magnetic pole strength, magnetic induction. Magnetic field intensity, generally if you look at ampere per meter, directly you can take up, right? And magnetic flux, when you talk about, it is Weber, that is for B is G and A is H. Now next one, magnetic pole strength, ampere meter, that means C must be related to E. And D, magnetic induction, Weber per meter square, D should be F. Then which is the correct option over here, correct match? Second option is going to be the correct match. So if you remember these units thoroughly, such models also are expected at Eamcet. In fact, this question has been given in recent years in one of the Eamcet papers only. Remember that one. Look at the next number, that is problem number 11. A bar magnet of length 10 centimeter and magnetic moment 1 ampere meter square is placed along the side AB of an equilateral triangle ABC. If the length of the side AB is 10 centimeter, the magnetic induction at the point C is how much? Indirectly he is asking in this question, what is magnetic induction on the equatorial line of the bar magnet? That is what he is asking. This is equilateral triangle. This is 10 centimeter he gave. This also 10 centimeter he gave. This one is say north pole. This one is say south pole. Is not this one called equatorial line, please? Is it not the point that is called C, please? So this is A, this is B, then automatically that is the point C. So out of this total length, what will be this length, please? Now it is 5 centimeter. this is 10, this is 5. Then what will be this value? According to Pythagoras theorem, root 75, that is 5 root 3 centimeter I can write. So what is this 5 root 3 here now? It is either you can call it D or you can call it R, that is 5 root 3 centimeter. You can otherwise write 5 root 3 into 10 power minus 2 meter as such. Now come on, tell what is the value of pole strength he has given you. 1 ampere meter square he has given magnetic moment directly. 1 ampere meter square. It is on the equatorial line. What is magnetic induction is the question. Magnetic induction is in Tesla. B is equal to mu naught by 4 pi into m by d cube. Mu naught by 4 pi is 10 power minus 7, it's okay. M is 1, whether you write that one or not hardly matters. What is this d cube in this case? That distance itself I am taking it as r. What will be r cube now? 5 root 3 whole cube. That is actually the case. That means 5 root 3 into 10 power minus 2 whole cube. I should write that way. Now automatically this becomes 10 power minus 1. By this becomes 10 power minus 3. So totally how much? Plus 3, of course, 10 cube you will be getting here. So what will be the total answer over here? It comes to be around 10 power minus 4. 10 power minus 4 what? Tesla. That will now be the corresponding answer for this. Look at those options carefully. Fourth option is going to be correct for this question number 11 as such. Now look at the next problem, that is problem number 12. Look at that one now. A short magnetic needle is pivoted in a uniform magnetic field of induction 1 Tesla. Now simultaneously another magnetic field of induction root 3 Tesla is applied at right angles to the first field. The needle deflects through an angle theta whose value is something. What is that angle is the question he is asking. Now look at carefully first of all. This is the first field. What is the value given? 1 Tesla. Fine. Now magnet is in this particular direction initially, let us say. Now this is north pole, this south pole. Now he is applying a force over here. What is that particular field he has given you? Root 3 Tesla he gave. Now you can certainly understand that magnet now neither stays in this direction nor comes into this particular direction. It now takes a resultant direction like this. Resultant direction means from this if it is making an angle theta, what will be this angle now? 90 minus theta. That is the concept one has to understand. So what is the concept? Theta means what again? You can understand now the torque that is acting over here must be the same. That means sin theta over here, right? And this one is sin 90 minus theta. Come on, just equating these two. Torque acting on the first one and torque acting on the second one. Directly already this type of a model we have taken up earlier. So similar concept, if we take up the angle theta now becomes exactly 60 degrees. What for you people can better understand? It is B1 sin theta is equal to B2 sin 90 minus theta. That is the concept. Sin 90 minus theta, of course, you can write that one cos theta. Then what will be the value of tan theta here, please? Tan theta is equal to B2 by B1. B2 is this one, B1 is this one. Root 3 directly you people can take up theta will be 60 degrees. Straight answer which is tallied with fourth option in this particular question as such. Look at the next number, that is problem number 13. A short bar magnet is arranged with its north pole pointing geographical north. Look at carefully, north pointing north, that is nothing other than tan B position, please. What do you mean by tan B position here? BH tan theta must be equal to mu naught by 4 pi into m by d cube. That should be the formula for tan B position. And at null point I have already told you tan theta becomes tan 45 which now becomes 1. So that is the point. It is found that horizontal component of Earth's magnetic induction is balanced by the magnetic induction of the magnet at a point which is at a distance 20 centimeter from its center. That means the distance is given 20 centimeter. You can even write that one 0.2 meter as such. What else he has given you? You see there, magnetic horizontal component of Earth's magnetic field BH value is given 4 into 10 to the power minus 5 Tesla. That itself he has given Weber per meter square as such. Now what is magnetic moment? The question. Magnetic moment means what is this value? We all know. So BH is equal to 10 power minus 7 into m by d cube, official formula. Now m becomes BH into d cube whole divided by 10 power minus 7. What are the values he has given? You substitute 4 into 10 power minus 5 into d cube. 0.2 whole cube means 2 into 10 power minus 1 whole cube. I write 8 into 10 power minus 3 whole divided by 10 power minus 7. Now this one gets cancelled minus 2 times, this one gets cancelled minus 1 time. Now 4 into 8, it is 32 into 10 power minus 1. So how much it will now be? 3.2. That must be in ampere meter square. So what is the correct option over there? You see 3.2 ampere meter square means the very first option that is tallied for with this particular answer what we have calculated. Look at the next number, that is problem number 14. A bar magnet of 10 centimeter length is kept with its north pole pointing geographical north. A neutral point is formed at a distance of 15 centimeter from each pole. Given the horizontal component of Earth's magnetic field as 0.4 Gauss, pole strength of the magnet is how much? More or less the same model once again. Same question has been repeated in one of the Eamcet examinations over there. BH, now what is that value he is giving you? You just check that. It is 0.4 Gauss. 0.4 into 10 power minus 4 Tesla. This is now 10 power minus 7. Small m into 2L, you better write this one, by what is the distance mentioned? 15 centimeter. So 15 into 10 power minus 2 whole cube you write. What is this question there? What is a small m and what is the length given? 10 centimeter. So directly you write small m is equal to 0.4 into 10 power minus 4, 4 into 10 power minus 5 into 15 cube, right, into 10 power minus 6 divided by this value 10 power minus 7 into the length is 10 centimeter he has given you there, that is 10 into 10 power minus 2 meter. You can write, you can even write 0.1 also. I am talking about just like this. Now 10 to the power minus 6 that cancels here minus 1 time. And 10 power minus 1, 10 power minus 2, total 10 power minus 3, that cancels minus 2 times. This going up, so automatically 4 into 225 into 15 into this going up means 10 power minus 3. So whatever the value you will be getting in ampere meter, that now should be the correct option for this one. How much you will be getting for this? Around 13.5 exactly you will be getting for this particular answer. 13.5 ampere meter will now be the corresponding pole strength. So this also is one of the Eamcet questions of previous years. Let us check the next number. Problem 15. 4 magnets of magnetic moments m, 2m, 3m and 4m are arranged in the form of a square such that unlike poles are in contact. Then the resultant magnetic moment will be how much? One of the excellent models of magnetism what we have. You can see now there is a square like this. Each side is a magnet. That in what way? Say north, south, north, south, north, south, north, south. That is the case. And he is talking about this one is of moment m, this one is of 2m, this one is of 3m and this one is of 4m. How to calculate the resultant? Easiest process I just explain you. This is m. You better take this one as m plus m. You better take this one as m plus 2m. You completely take this one as m plus 3m. Now look at carefully, when opposite poles are here, won't they be getting cancelled? This m, this m, this m and this m. All the 4 they get cancelled. That means this particular magnet will be nullified now totally. So what is now left over? Look at, you have only 3 sides left. This one is south, this one is north, this one is south, north and this one is south over here. This one is north, this one is south. What is its magnetic moment now? It is only m. This now is only 2m. This now is 3m. Observe very carefully now. What is the direction of this magnetic moment? South to north. This is the direction of m. What is its magnetic moment, you see? South to north. This is the direction of 3m. Simple common sense. 3m that side and m this side. What will be the resultant of these two? It is 3m minus m. How much it will now be? 2m. The resultant of these two is 2m and the third magnet is already 2m. Now one 2m is here, other 2m is here. Are they not perpendicular to each other, please? Then what can we write the angle between them? 90. Then is not 2m root 2 will now be the resultant magnetic moment, please. 2m root 2, how to rewrite that one? You can write that one 2 root 2 times m. That is going to be the correct option for this question number 15 as such. One of the best models. This is the easiest processes in which you can solve this model question. Now look at the next number, problem 16, please. The field intensity at 2 points on the axial line of a bar magnet distance is 40 centimeter and 20 centimeter is 10:125. Length of the magnet is how much? That is the concept. On the axial line means the formula is known to all of us. It is B is equal to mu naught by 4 pi into 2md by d square minus L square whole square, because he is not giving that this magnet is a short magnet and that too he is asking you the length part of it. Therefore, you should take this formula. What is the ratio he has given you? B1 by B2. B1 by B2 means 1 by 4 pi, mu naught by 4 pi constant, 2 constant, okay. M is same magnetic moment constant. Then what can I write? D1 by D2 into d2 square minus L square whole square by d1 square minus L square whole square. I can write like this. What is b1 by b2 given? It is 10 by 125. Fine. d1 by d2. d1 is given 40 and d2 is given 20. So 40 by 20 into 20 square 400 minus L square whole square by 40 square 1600 minus L square whole square. I can write. This goes twice. Bring that 2 down. Then what happens to this one now? This now becomes 10 by 250. That means 1 by 25 is equal to 400 minus L square whole square by 1600 minus L square whole square. Just to take root on both sides. Then what will you get? 400 minus L square by 1600 minus L square is equal to 1 by 5. Simply cross multiply and find out L. You will be getting exactly 10 centimeter. But 10 centimeter is not the length of the magnet. Length of the magnet always will be 2L. This is to be remembered very carefully. Otherwise, 10 centimeter he has given you the first option there, which is not correct. Length is 2L. 2L now becomes 20 centimeter. That means what is the correct option over here? Fourth option is the correct option for this question number 16, please. Look at the next one, that is problem 17. A magnet of length L and magnetic moment capital M is cut into 2 equal halves perpendicular to its axis. One piece A is bent into a semicircle of radius R and is joined to the other piece at the poles as shown. Assuming that the magnet is in the form of a thin wire initially, the magnetic moment of the system is how much? One of the simplest models over here. This also has been one of the previous Eamcet questions like. He has just made one piece like this, another piece straight like this. Say that fellow said this is south north, this one is south, this one is north. Then you can definitely understand what is its moment now. Its moment is 2m by pi. But m is already becoming m by 2. So 2m by 2 by pi. What will be this magnetic moment now? M by 2. That is m2. Now what will be the resultant magnetic field? You should write m1 plus m2. Then m by 2, suppose if you take common, 2 by pi plus 1 you will be get. That in the sense what? M by 2 pi into 2 plus pi. Just look at this option where he has given you m by 2 pi into 2 plus pi, that is option number 3. So this is the method of taking this type of a model, that is problem 17. Look at the next one, that is problem number 18. Two short magnets AB and CD in the xy plane and are parallel to x-axis, and the coordinates of their centers are respectively 0, 2 and 2, 0. Line joining the north-south poles of CD is opposite to that of AB and lies along positive x-axis. The resultant field induction due to AB and CD at a point P 2, 2 is 100 into 10 power minus 7 Tesla. When the poles of the magnet CD are reversed, the resultant field induction is 50 into 10 power minus 7 Tesla. The values of magnetic moments of AB and CD in ampere meter square are. This is once again Eamcet question, earlier Eamcet question. He is now giving you how he has placed two magnets. One is of course AB and one is CD. Both are parallel to x-axis and AB is at 0, 2. That means you should understand it is on y-axis like this. And of course this is on x-axis like this. This is AB, what he is talking. This is CD, what he is saying. Now of course you can understand this point is going to be at a 2 meter distance this way. This point once again the center is at a 2 meter distance this way. Now fine, what is the clause he has given? Line joining north-south poles of CD is opposite to that of AB, lies along positive x-axis. Which one? North-south. This is north, this is south. This is the line. Here this is north, this is south, this is the line. Just both are quite opposite. Now he is talking there is a point here. At what distance it is located? 2, 2. That means x value 2, y value 2. Now you can understand that point according to this magnet, it is on the axial line. So this will be the direction of B axial. And for this particular magnet, that is on the equatorial line. What is its direction once again? B equatorial also is going to be the same. So I can write this one as M1 and this one as M2. That is the case. Now you tell what will be the resultant he is talking about. Resultant is given 100 into 10 power minus 7, which is equal to mu naught by 4 pi 10 power 7 into 2m1 by d cube, that is 2 cube, plus m2 by d cube, that is m2 by 8. What is the second one he has given? He has reversed CD, then automatically B equatorial's direction will be varied. 50 into 10 power minus 7 is equal to 10 power minus 7 into 2m1 by 8 minus m2 by 8. One is with positive sign, one is with negative sign. Simply solve these two, you will be getting the first magnetic moment M1 as 300 and second magnetic moment M2 as 200. Look at these options carefully please. 300 and 200 ampere meter square as such, that option is going to be tallied with the first option of this particular question 18. Look at the next number, that is problem number 19 please. The magnetic induction at a distance d from the magnetic pole of unknown strength m is B. Magnetic induction is B. That means it's a direct formula application. B is equal to mu naught by 4 pi into m by d square. That's all. That is first. What next he is asking? If an identical pole is now placed at a distance 2d from the first pole, the force between them. Force now becomes mu naught by 4 pi m1 m2 by d square. That of course m square by 2d square, that is 4d square. Can't you simply write this one as m by 4 into b please? So bm by 4, look at that option please. Third option, that is going to be tallied with this particular answer, that is mb by 4. That is question number 19. Look at the next number, that is problem 20. Two short bar magnets P and Q are arranged such that their centers are on the x-axis and are separated by a large distance. Magnetic axis of P and Q are along x and y axis respectively. That is the concept what you have to take up. One is of course on the x-axis like this. One of course is now placed on the x-axis only, but like this. That is what he is talking. So one is perpendicular to the other, and what is he giving you? At a point R, midway between their centers, if B is the magnetic induction due to Q, this is P, this is Q. This is midway the point R. Then you can certainly understand that is equatorial line for us. This distance you take it d by 2. This distance you take it d by 2. Then what is the value of B that is given now? Mu naught by 4 pi into this value of mq by d by 2 whole cube. That is the first equation. Look at the next one. What is the magnetic induction due to the total? Total in the sense what? If you take this one is north and this one is south. Here this is B axial and of course this is B equatorial. Then are they not perpendicular to each other, please? When you take this one, what will now be the resultant value? One is this one 2m by d cube, that is m by d cube. If you take root 2 square plus 1, it now becomes root 5. Root 5 times the value of B will now be your answer. That is the option second is going to be tallied with this particular question, please. Look at the last number, that is 21st. Two magnetic isolated north poles, each of pole strength m ampere meter, are placed one at each of the two vertices of an equilateral triangle of side A. Resultant magnetic induction at the third vertex. This can be worked out in a very easy manner. An equilateral triangle is talking. There is a pole here m, there is another pole here m. This side is, say for example, A. What is the magnetic induction at the third vertex? Vertex means the distance is A. Imagine a unit north pole. This repels it like this with a force. This repels it like this with a force. What will be the angle between them? 60. What is magnetic induction? It is resultant force acting on the unit north pole. Is it not F root 3, please? What is F formula? Mu naught by 4 pi m by a square into root 3. Just see the options carefully. Mu naught by 4 pi should be there. M by a square should be there. Into root 3 should be there. So which option is tallied over there? Third option that is going to be tallied. So if you look at magnetism chapter thoroughly this way, what are all the questions we have taken today? You might have already got. Other than the concepts of deflection magnetometer and vibration magnetometer, along with the Earth's magnetic components, both those concepts barring them, the remaining topic of this magnetism chapter we have discussed today. So in the next session, we are going to take up the remaining concepts of this particular chapter magnetism, which of course is going to be a very important part of this chapter. One is deflection magnetometer and its applications we have to take up, and second one vibration magnetometer with its applications we people have to discuss about. So till then, just work out some of the questions based on these topics, right? We shall discuss the remaining later. Thank you.